You know, when we left off in our last conversation about God and physics, we had explored some of the fundamental questions about the relationship between science and spirituality, between the material world and the transcendent, between what we can measure and what we can only wonder about. And I think we barely scratched the surface, because the question of God's existence, or more precisely, the question of whether the universe requires something beyond itself to explain its existence, is so deep, so multifaceted, so profound, that we could talk about it for hours and still not exhaust all the angles. So that's what we're going to do today. We're going to dive deeper. We're going to explore the arguments for and against God's existence from the perspective of modern physics. We're going to look at the fine-tuning of the universe, the origin of the laws of nature, the question of why there's something rather than nothing. We're going to examine consciousness, free will, the arrow of time, and what quantum mechanics might tell us about the nature of reality itself. And I want to be clear from the outset, I'm not here to prove or disprove God's existence. That's not something physics can do. What I want to do is show you how modern physics has changed the terms of the debate, how it's revealed aspects of reality that seem to cry out for explanation, and how different people interpret that evidence in radically different ways. Some physicists look at the equations of quantum mechanics and see God's signature. Others see the same equations and conclude that God is unnecessary, that the universe can explain itself. And both groups are looking at the same evidence, the same mathematics, the same experimental results, which tells you something important. This isn't just a scientific question. It's a philosophical question, an interpretive question, a question about what kind of explanations satisfy us. So let me start by presenting what I think is the strongest argument for something like God, or at least for something transcendent beyond the physical universe. And that argument comes from what we call the fine-tuning of the universe. Here's what we've discovered over the past century. The universe appears to be exquisitely fine-tuned for the existence of complexity, structure, and ultimately life. The fundamental constants of nature, things like the strength of gravity, the mass of the electron, the cosmological constant, all have very specific values. And if those values were even slightly different, the universe would be radically different in ways that would preclude the existence of stars, planets, atoms, or any kind of complex chemistry. Let me give you some examples to make this concrete. The strength of the strong nuclear force, the force that holds atomic nuclei together, is about 1% of what it needs to be to bind protons and neutrons into nuclei. If it were just a few percent weaker, hydrogen would be the only element in the universe. No carbon, no oxygen, no chemistry, no life. Everything would just be hydrogen atoms floating in space. On the other hand, if the strong force were a few percent stronger, hydrogen nuclei would bind together so tightly that there would be no hydrogen left. It would all have fused into heavier elements in the early universe, which means no water, no organic chemistry, no DNA, no life as we know it. So there's this incredibly narrow range where the strong force has to be for chemistry to work, for elements to form, for complexity to be possible. And remarkably, that's exactly where it is. Or consider gravity. Gravity is incredibly weak compared to the other forces. It's about 10 to the 39 times weaker than the electromagnetic force. That's a 1 followed by 39 zeros. Why is it so weak? We don't know. But we do know that if gravity were significantly stronger, stars would burn out too quickly. They'd collapse under their own weight, fusing their fuel in millions of years instead of billions. No time for planets to form, for life to evolve. And if gravity were significantly weaker, matter wouldn't clump together in the first place. No galaxies, no stars, no planets, just a thin, diffuse soup of particles spreading out forever. Then there's the cosmological constant dark energy, that peculiar number we talked about before, 10 to the minus 120. If it were much larger, the universe would have expanded so fast that matter couldn't clump into galaxies. If it were much smaller or negative, the universe would have collapsed back on itself almost immediately after the Big Bang. And there are dozens of these parameters. The mass ratio of protons to electrons, the fine structure constant that determines the strength of electromagnetic interactions, the difference in mass between neutrons and protons. The ratio of matter to antimatter in the early universe, each of these has to be within a very narrow range for the universe to support complexity and life. Change any one of them significantly, and you get a sterile universe, either one where matter can't form stable structures, or one where everything collapses immediately, or one where stars can't shine, or one where chemistry doesn't work. Now, when physicists first started realizing this in the 1960s and 70s, it was shocking. It seemed almost too convenient, too suspicious. The universe looks designed. It looks like someone set the dials very carefully to produce a universe capable of supporting observers like us. And this led to what's called the anthropic principle, which comes in different flavors, but basically says, of course the universe looks fine-tuned for us. If it weren't, we wouldn't be here to observe it. It's a selection effect. We necessarily find ourselves in a universe compatible with our existence, regardless of how improbable such a universe might be. But that doesn't really answer the question, does it? It just restates it. Yes, we can only observe a universe that permits observers. But why does such a universe exist at all? Why is there a universe with these particular finely tuned values rather than no universe, or a universe with random values that doesn't support complexity? Some people look at this fine tuning and see the hand of God. They say, this isn't a coincidence. The universe is fine-tuned because it was designed by an intelligent creator who wanted to produce a universe capable of supporting life and consciousness. The fine-tuning is evidence of purpose, of intention, of design. And I have to admit, there's something compelling about this argument. The probability of getting all these parameters right by chance seems astronomically small. If you randomly selected values for all the fundamental constants, the odds of getting a life-permitting universe would be vanishingly tiny, maybe 1 in 10 to the 100, or 1 in 10 to the 500, depending on how you calculate it. Those are absurdly small probabilities. To give you a sense of scale, the odds of winning the Powerball lottery are about 1 in 300 million. The odds of winning it twice in a row are about 1 in 10 to the 17. The odds of the universe being fine-tuned by chance are vastly, vastly smaller than that. So if you're a religious person, or if you're philosophically inclined toward theism, the fine-tuning argument seems pretty strong. It seems to suggest that the universe is not an accident, that there's something, some intelligence, some purpose, some mind behind it all. But here's where physics offers an alternative explanation, one that doesn't require God, and that's the multiverse. Remember from our previous conversation, if there are many universes, perhaps infinitely many, each with different values for the fundamental constants, then the fine-tuning puzzle dissolves. Because out of all those universes, some will randomly have the right parameters for life. And we necessarily find ourselves in one of those rare universes because we couldn't exist in any of the others. It's exactly like the anthropic explanation, but taken to a cosmic scale. We're not surprised to find ourselves on a planet with liquid water, oxygen, and moderate temperatures, even though such planets are rare, because we couldn't exist on planets without those features. Similarly, we shouldn't be surprised to find ourselves in a universe with fine-tuned constants, even if such universes are rare, because we couldn't exist in universes without fine-tuning. So, the multiverse offers a naturalistic explanation for fine-tuning. No need for God, no need for design, just an enormous number of universes trying all possible combinations of parameters, and we happen to be in one of the lucky ones. Now, some people find this explanation completely satisfying. They say fine-tuning is no longer mysterious once you accept the multiverse. is just selection bias, anthropic reasoning applied on the largest possible scale. But other people, and I have some sympathy for this view, find the multiverse explanation unsatisfying, even evasive, because you're explaining one seemingly improbable thing, our fine-tuned universe, by postulating something even more extravagant, infinitely many universes, most of which we can never observe or verify. It's a bit like this. Imagine you're dealt a royal flush in poker 10. Jack, queen, king, ace, all in the same suit. The odds of that are about 1 in 650,000. You'd be suspicious, right? You'd think maybe the deck was stacked. Maybe someone arranged the cards deliberately. Now, someone could say, no, it's not suspicious at all. There are billions of poker games being played across the multiverse, so somewhere, someone had to get a royal flush. You just happened to be that person. Technically true, but it doesn't really explain why you got the royal flush. It just says that someone had to. Similarly, the multiverse says that some universe had to have fine-tuned constants, and we're in it. True, but it doesn't explain why there's a multiverse in the first place, or why the multiverse has the particular structure it does. Why string theory? Why inflation? Why these laws of physics that generate multiverses rather than some other laws or no laws at all? So you can see how this debate goes. Each explanation, God or multiverse, has its strengths and weaknesses. Each requires accepting something extraordinary, either a transcendent intelligence or an infinity of unobservable universes. Neither is provable. Both require a leap of faith, in some sense. And this is why physics can't definitively answer the God question. We can lay out the evidence, we can describe the theoretical frameworks, but ultimately the interpretation is philosophical, not scientific. But let me push a little further, because there's another aspect to the fine-tuning argument that's worth exploring, and that's the question of the laws of nature themselves. Even if we accept the multiverse as an explanation for the particular values of the constants, we still have to explain why there are laws of nature at all. Why does the universe follow mathematical rules? Why is it comprehensible? Why can we describe the behavior of particles and fields with equations? This is the question that Einstein was getting at when he said, the most incomprehensible thing about the universe is that it is comprehensible. And it's what Eugene Wigner meant when he wrote about the unreasonable effectiveness of mathematics in the natural sciences. Why should mathematics, this abstract system of logic that we develop in our minds, correspond so precisely to physical reality? Why should the equations we write on blackboards describe how galaxies move, how atoms bond, how fields propagate through space? It's not obvious that the universe should be mathematical. You could imagine a universe that's fundamentally chaotic, unpredictable, not governed by rules, or you could imagine a universe that has some regularities but isn't precisely mathematical, where the rules are approximate or fuzzy or context dependent. But our universe is exquisitely mathematical. Not just approximately, but exactly. As far as we can tell, the laws of physics are precise mathematical relationships that hold everywhere and always, without exception. And this is amazing. This is profoundly strange if you really think about it. The universe didn't have to be this way, but it is. Now, if you believe in God, this makes sense. God is a mathematician in some sense. God created a rational, ordered universe that reflects divine intelligence. The mathematical structure of reality is a reflection of the mathematical mind of the Creator. Plato thought something like this. He believed in a realm of perfect mathematical forms that exists beyond the physical world, and that physical reality is somehow a shadow or reflection of this higher mathematical realm. And for Plato and many philosophers and theologians who followed him, this mathematical realm was closely associated with the divine mind. But if you don't believe in God, you have to explain why the universe is mathematical without invoking a designer. And that's tricky. Some physicists and philosophers say the universe is mathematical because mathematics is the only coherent way for a universe to be. Anything that exists must have some structure, some patterns, some regularities. And structure, patterns, and regularities just are mathematics. So a universe that exists must be mathematical by definition, but I'm not sure that fully answers the question, because there are many possible mathematical structures, infinitely many, in fact. Why this particular mathematics? Why these particular equations? Why quantum mechanics and general relativity rather than some other mathematical framework? And here's where some people invoke something called the mathematical universe hypothesis, proposed by physicist Max Tegmark. The idea is that all mathematical structures exist in some sense, and physical reality is just one particular mathematical structure, the one we happen to inhabit. In this view, there's no distinction between mathematics and physics. Physical reality is mathematical reality. The universe doesn't just obey mathematical laws, it is a mathematical structure. This is a radical idea, and it dissolves the question of why the universe is mathematical, because in this framework, being mathematical is what it means to exist. But again, this seems to push the mystery back rather than solving it. Why do mathematical structures exist at all? Why is there something rather than nothing? And if all mathematical structures exist, why do we find ourselves in this particular one? These are the kinds of questions that physics can describe but not ultimately answer. We can map the terrain, we can show you the various positions people take, we can explain the arguments for and against each view, but at some point you hit bedrock fundamental questions that might not have scientific answers. And I think that's okay. I think it's important to recognize the limits of scientific explanation. Science is incredibly powerful within its domain, describing how the universe works, what the patterns are, what we can predict and test. But science might not be able to tell us why there's a universe in the first place, or whether there's purpose or meaning behind it. Those are metaphysical questions, philosophical questions, perhaps spiritual questions, and different people will answer them differently based on their worldviews, their intuitions, their experiences, their philosophical commitments. Now, let me shift to another aspect of this debate, because I want to talk about the origin of the universe itself, because this is where the God question becomes most acute. The Big Bang Theory tells us that the universe had a beginning roughly 13.8 billion years ago. Space and time themselves came into existence. Before that moment, there was no before. Time itself didn't exist. And this raises an obvious question. What caused the Big Bang? What brought the universe into existence? For centuries, this was considered a question beyond the reach of science. Science describes how things change over time, but if time itself had a beginning, how can science explain what came before? You need time to have causation, to have events, to have change. So the origin of time itself seemed to be outside the scope of scientific investigation. And many religious thinkers seized on this as evidence for God. If the universe had a beginning, something must have caused it to begin. And that something, by definition, must be outside the universe, beyond space and time, transcendent. That sounds an awful lot like God. This was one of Thomas Aquinas' arguments for God's existence in the 13th century, the cosmological argument, or the argument from first cause. Everything that begins to exist has a cause. The universe began to exist. Therefore, the universe has a cause. And that cause is God. Now, the Big Bang gives this argument a modern scientific foundation. We're not just speculating philosophically about whether the universe had a beginning. We have observational evidence that it did. We can see the cosmic microwave background, the afterglow of the Big Bang. We can measure the expansion of space. we can calculate back to those first moments when everything was compressed into an infinitely hot, infinitely dense point. So modern cosmology seems to vindicate the intuition that the universe needs a cause, a creator, something beyond itself to explain why it exists. But here's where physics gets really interesting. Because over the past few decades, physicists have developed ideas about how the universe might have come into existence without requiring a supernatural cause. One idea is that the Big Bang wasn't the beginning of everything, it was just a transition, a phase change in some larger eternal structure. Maybe the universe has always existed in some form, and what we call the Big Bang was just a moment of dramatic transformation. Another idea involves quantum mechanics. In quantum mechanics, particles can appear and disappear spontaneously due to quantum fluctuations. These are called virtual particles, and they're constantly popping into and out of existence in what we call the quantum vacuum. Now, the quantum vacuum isn't really nothing, it's a seething foam of quantum activity, a field that has a certain energy density even in its lowest energy state. But some physicists, like Lawrence Krauss, have argued that the entire universe could have emerged as a quantum fluctuation from this vacuum state. The idea is that in quantum mechanics, anything that's not forbidden is mandatory, given enough time. And there's no law of physics that forbids the spontaneous creation of a universe from the quantum vacuum. So eventually, inevitably, a universe will fluctuate into existence, and once it exists, if it has the right properties, if it undergoes inflation, as we discussed before, it will expand rapidly and evolve into something like the universe we observe. In this picture, the universe is literally a quantum fluctuation. It came from nothing, or at least from the quantum vacuum, which is as close to nothing as you can get in physics. No creator required. Just the laws of quantum mechanics operating on the vacuum. Now, religious thinkers and some philosophers have pushed back on this. They say, wait a minute, the quantum vacuum isn't really nothing. It's a quantum field with certain properties governed by the laws of quantum mechanics. So you haven't explained where the quantum vacuum came from or where the laws of quantum mechanics came from. You've just pushed the mystery back one step. And they have a point. Krauss's universe from nothing isn't really from nothing in the philosophical sense. It's from a quantum vacuum that already has structure, that already obeys laws, that already has the potential to generate universes. So the deeper question remains, why is there a quantum vacuum? Why are there laws of quantum mechanics? Why is there something rather than nothing in the most fundamental sense? And physics doesn't have an answer to that. Maybe there is no answer. Maybe why is there something rather than nothing is a question that doesn't have a meaningful answer. Like, what's north of the North Pole? Maybe existence is just a brute fact that doesn't require explanation. Or maybe the answer is God. Maybe there's a transcendent creator who brought the laws of nature, the quantum vacuum, and the universe itself into existence. Both positions are defensible. Both require making philosophical assumptions that go beyond what physics can prove. And this is why reasonable people can look at the same cosmological evidence and reach different conclusions. But let me push on this a little more, because I think there's a fascinating aspect to quantum mechanics that's relevant to the God question, and that's the measurement problem we touched on before. Remember, quantum mechanics describes particles as existing in superpositions, being in multiple states at once until a measurement is made. And when a measurement is made, the superposition collapses to a single definite state. But what counts as a measurement? What causes the collapse? This is the measurement problem, and it's one of the deepest unsolved questions in physics. One interpretation, the Copenhagen interpretation, says that measurement, observation, consciousness plays a special role. When a conscious observer looks at a quantum system, that's when the collapse happens. Now, Most physicists are uncomfortable with this because it seems to give consciousness a fundamental role in physics. And we don't have a theory of consciousness. We don't know what it is or how it arises. So building it into the foundations of quantum mechanics seems problematic. But some people have embraced this idea and taken it further. They've argued that consciousness is fundamental to reality, that the universe requires observers to exist in a definite state, and that this points to something like a cosmic consciousness, a universal mind that observes everything, that collapses all the quantum wave functions, that brings definiteness into existence. And that sounds an awful lot like God. A God who isn't just a creator who started things off and then stepped back, but an active, ongoing presence that's involved in every quantum event, every measurement, every moment when possibility becomes actuality. This is a minority view among physicists, but it's not fringe. There are serious thinkers who've explored this idea, people like Freeman Dyson, Bernard Despaignat, Henry Stapp. They've argued that quantum mechanics points to something beyond purely physical reality, something mental or conscious at the foundation of existence. But the majority view is different. Most physicists who think carefully about the measurement problem favor interpretations that don't give consciousness a special role. The many worlds interpretation, for instance, says there's no collapse, all possibilities happen, each in a different branch of reality, no consciousness required. Or decoherence theory says that the apparent collapse is due to interaction with the environment, not observation by a conscious being. The quantum system gets entangled with its surroundings, and this creates the appearance of definite outcomes without requiring consciousness. So once again, we have physics that can be interpreted in radically different ways. Some see it pointing toward consciousness and possibly God. Others see it as purely mechanistic, with no need for anything beyond the physical. And I'll tell you honestly, I don't know which interpretation is correct. The measurement problem is genuinely unsolved. We don't know how to think about the transition from quantum possibility to classical actuality. And until we solve that problem, if we ever solve it, the door remains open to different philosophical interpretations. Now, let me shift gears again, because I want to talk about something that's perhaps even more personal, more immediate than cosmology or quantum mechanics. And that's consciousness itself. Because one of the most common arguments for something beyond the physical, if not God exactly, then at least some non-material aspect of reality comes from the fact of consciousness, the fact that we have subjective experiences, that there's something it's like to be us. You're reading these words right now, and you're having an experience. You're aware. There's a felt quality to your perceptions, your thoughts, your emotions. Philosophers call this quality the subjective first-person character of experience. And here's the puzzle. How does consciousness arise from physical matter? How do neurons firing in your brain give rise to the felt experience of seeing red, or tasting chocolate, or feeling love, or thinking about mathematics? This is called the hard problem of consciousness, and it's genuinely hard. We've made enormous progress in neuroscience. We can map brain activity, correlate neural patterns with mental states, understand the functional role of different brain regions, but we haven't explained how or why this neural activity generates subjective experience. It's one thing to say, when these neurons fire, you see red. That's a correlation. And we found many such correlations. But it's another thing entirely to explain why there's something it's like to see red, why there's a subjective experience associated with that neural activity. Some philosophers and scientists think this problem is fundamentally unsolvable within a purely physical framework. They argue that consciousness is something additional, something beyond the physical brain, perhaps non-physical, perhaps requiring new physics, perhaps pointing to a spiritual dimension of reality. This is called dualism, the idea that mind and matter are fundamentally different kinds of things. And if dualism is true, if consciousness really is non-physical, then that opens the door to all sorts of metaphysical possibilities, including God and the soul and an afterlife. But most neuroscientists and philosophers of mind are physicalists. They believe that consciousness is somehow produced by or identical to brain activity, even if we don't understand how yet. They think the hard problem will eventually be solved, that we'll figure out how physical processes give rise to subjective experience. And maybe they're right. Maybe consciousness is just what information processing feels like from the inside. Maybe once we understand the brain well enough, the mystery will dissolve. But maybe not. Maybe consciousness really is something more, something that can't be reduced to neurons and synapses and electromagnetic fields. And if that's true, it would be one of the most important discoveries in the history of science, that reality has aspects that aren't purely physical, that the universe is more than just matter and energy following mathematical laws. That wouldn't necessarily prove God's existence, but it would open up conceptual space for God in a way that strict materialism doesn't. So consciousness remains a frontier, a place where our scientific understanding is incomplete, where mystery remains. And reasonable people can interpret that mystery differently, some seeing it as a gap that science will eventually fill, others seeing it as evidence of something transcendent. Let me come at this from yet another angle, because there's one more aspect of physics that's relevant to the God question, and that's the arrow of time. We experience time as flowing from past to future. We remember the past, but not the future. We can influence the future, but not the past. Eggs break, but don't unbreak. Coffee cools, but doesn't spontaneously heat up. Entropy increases. This directionality of time, the arrow of time, is built into our experience of reality. But here's the weird thing. The fundamental laws of physics don't have an arrow of time built into them. The equations work just as well running backward as forward. If you film a billiard ball collision and play it backward, it still looks physically plausible. The reversed motion obeys the same laws of physics as the forward motion. At the fundamental level, time is symmetric. So where does the arrow of time come from? Why does time seem to flow in one direction if the laws of physics don't care which direction time goes? The standard answer involves entropy and the second law of thermodynamics. Entropy, roughly disorder or randomness, always increases in closed systems. And this gives time a direction. The future is the direction of increasing entropy. But this just pushes the question back. Why did the universe start in a low entropy state? Why was the Big Bang, that incredibly hot, dense, uniform state, actually a state of very low entropy? If the universe had started in a high entropy state, time wouldn't have a direction, or the direction would be different. So the arrow of time depends on the particular initial conditions of the universe, which seem very special, very unlikely. And once again, we can interpret this as pointing toward design. God set up the initial conditions carefully to produce a universe with an arrow of time, a universe where memory and causation and agency are possible. Or we can interpret it naturalistically. Maybe the low entropy beginning is explained by inflation, or by the multiverse, or by some other physical mechanism we haven't discovered yet. Same evidence, different interpretations. I could go on. I could talk about free will and determinism, about whether quantum randomness gives us genuine freedom, or whether we're just sophisticated machines following the laws of physics. I could talk about the unreasonable effectiveness of mathematics, about whether numbers and equations are human inventions or discoveries of something real and transcendent. I could talk about beauty and elegance in physics, about whether the fact that the laws of nature are mathematically beautiful tells us something about the universe's origin and purpose. But I think I've made my point. Physics has revealed a universe that's exquisitely fine-tuned, deeply mathematical, mysteriously quantum, surprisingly comprehensible, and filled with phenomena consciousness Time's arrow, the very fact of existence that cry out for explanation. And some people look at all this and see God's handiwork. They see purpose, design, intelligence, a cosmic mind behind it all. And they're not being irrational or unscientific. They're interpreting the evidence in a particular philosophical framework. Other people look at the same evidence and see no need for God. They see natural processes, elegant mathematics, quantum mechanics, perhaps a multiverse, but nothing that requires supernatural explanation. And here's what I think is crucial to understand. Physics can't adjudicate between these views. We can describe the universe in exquisite mathematical detail. We can make predictions and test them. We can push back the boundaries of the unknown. But at some point, we hit questions that are beyond the reach of scientific investigation. Questions about ultimate origins, ultimate purposes, ultimate meanings. Questions about why there's something rather than nothing, about whether reality is fundamentally physical or has non-physical aspects, about whether the universe is purposeful or accidental. These are philosophical questions, metaphysical questions, perhaps spiritual questions. And reasonable people can disagree about them while agreeing on all the scientific facts. So when you ask me, does physics prove or disprove God's existence, my answer is, it does neither. What physics does is constrain the conversation, clarify the questions, reveal aspects of reality that we need to account for in any worldview, whether theistic or atheistic. Physics tells us that the universe began in a Big Bang 13.8 billion years ago. How you interpret that beginning, whether as a spontaneous quantum fluctuation or as an act of creation, depends on your philosophical framework. Physics tells us that the universe is fine-tuned for complexity and life. Whether you explain that through a designer or through a multiverse depends on which explanation you find more compelling, which costs you're willing to pay. Physics tells us that reality is quantum at its foundation, with all the strange implications that brings. Whether you see that as pointing toward consciousness and perhaps a cosmic mind, or as purely mechanistic processes we don't fully understand yet, depends on how you interpret the measurement problem and related issues. And physics tells us that we're conscious beings in a mathematical universe able to comprehend the cosmos through abstract reasoning. Whether you see that as a remarkable accident or as evidence of a rational creator depends on your intuitions about the relationship between mind and matter, between mathematics and reality. I don't have definitive answers to these questions. I don't think anyone does. What I have is appreciation for the depth of the mystery, respect for people on both sides of the debate who are thinking carefully about these issues, and awe at the fact that we're able to ask these questions at all. We're pattern-seeking primates on a small rocky planet orbiting an average star in an unremarkable galaxy, and yet we figured out quantum mechanics and general relativity, and we're having sophisticated debates about the ultimate nature of reality and whether God exists. That's extraordinary. That's something to marvel at, regardless of where you come down on the God question. So let me continue. Because we've only scratched the surface of how physics intersects with theology, with philosophy, with our deepest questions about existence and meaning. And I want to dig deeper into something I mentioned earlier, because I think it's one of the most profound puzzles in all of physics, and it's directly relevant to whether the universe requires something beyond itself to explain its existence. And that's the question of why the laws of nature have the form they do. When we write down the equations of physics, whether it's Maxwell's equations for electromagnetism or the Schrödinger equation for quantum mechanics or Einstein's field equations for gravity, we're describing patterns that the universe follows. These aren't just approximations or useful fictions. As far as we can tell, they're exact. They hold everywhere, always, without exception. But why these laws? Why these particular mathematical structures? Why does the universe follow rules at all? This might seem like an odd question. After all, if the universe didn't follow rules, we couldn't do science. We couldn't make predictions. We couldn't understand anything. So maybe the fact that there are laws is a precondition for asking the question in the first place. But that's not quite satisfying, is it? Because we can imagine different laws. We can write down different equations that would be perfectly consistent, perfectly mathematical, but that would describe a completely different universe. For instance, gravity could follow an inverse cube law instead of an inverse square law. That would be mathematically consistent. Or electromagnetic forces could have a different strength relative to gravity. Or quantum mechanics could have different commutation relations. Or space-time could have 5 spatial dimensions instead of 3. All of these would be coherent alternative laws of physics. They'd be different from what we observe, but they wouldn't be contradictory or impossible. They'd just be different. So why these laws and not others? Now, if you're religious, you have a straightforward answer. God chose these laws. Out of all the possible mathematical structures, all the possible ways a universe could be organized, God selected this particular set because it would produce a universe capable of supporting intelligent life, moral agents, beings who could know and love God. The laws are what they are because they were chosen for a purpose. And that's a deeply satisfying answer if you believe in God, because it explains both the fact that there are laws and why these particular laws. But if you don't believe in God, you need a different explanation. And that's where things get philosophically interesting. One possibility is the anthropic approach we've discussed. There are many universes with different laws, and we find ourselves in one with these laws because these are the only laws compatible with our existence. That's selection bias operating at the level of the laws of nature themselves. Another possibility is that there's some deeper principle we haven't discovered yet that constrains what laws are possible. Maybe these laws are the only ones that are mathematically consistent in some deep way. Maybe there are meta-laws, laws about laws, that determine which physical laws can exist. This is what string theorists hoped for initially. They thought string theory would uniquely determine the laws of physics, that there would be one consistent way to unify gravity and quantum mechanics, one unique solution, and that solution would give us our laws. But as I mentioned before, that hope was dashed when we discovered the landscape, 10 to the 500 possible solutions, each giving different laws. So string theory, as we currently understand it, doesn't narrow things down to a unique set of laws. A third possibility, and this is quite radical, is that the laws of physics aren't fundamental at all. They're emergent. They arise from something even more basic, something that isn't itself law-like in the way we usually think. There are some speculations along these lines. Maybe the fundamental reality is pure mathematics, all mathematical structures exist, and physical reality is just one of them. Or maybe the fundamental reality is something like a cosmic computation, and the laws of physics are like the operating system that emerges from the underlying computational substrate. Or maybe, and this is where some physicists get really speculative, maybe the laws themselves evolve. Maybe in the very early universe, or before the Big Bang, there were different laws, or no laws, or proto-laws, and the laws we observe emerged through some kind of cosmic natural selection or self-organization. Lee Smolin has proposed something like this: the idea that universes reproduce through black holes, and the parameters of the daughter universes are slightly different from the parent universe. Over cosmic time, this would lead to a population of universes that are tuned for producing lots of black holes, which happens to also mean they're tuned for producing stars and heavy elements and potentially life. It's a creative idea, but it's highly speculative and very difficult to test. Still, it's the kind of thinking that emerges when you take seriously the question of why the laws are what they are. But here's what strikes me about all these naturalistic explanations. They all push the mystery back without really solving it. If the laws are selected anthropically from a multiverse, why is there a multiverse with that structure? If the laws are determined by meta-laws, where do the meta-laws come from? If the laws emerge from pure mathematics, why does mathematics have the structure it does? If the laws evolve, what determines the mechanism of evolution? At every step, we're replacing one set of why questions with another set. And eventually, we reach a point where we have to say, this is just how things are. This is bedrock. This doesn't require further explanation. And the question becomes, where do you place that bedrock? Do you place it at God, an ultimate mind, an ultimate reality that doesn't require explanation because it's necessary, it couldn't not exist? Or do you place it at some fundamental physical or mathematical structure, the quantum vacuum, or the laws of physics, or the multiverse, or pure mathematics? Both require accepting something as brute fact. Both require stopping the chain of explanation somewhere. And I'm not convinced there's a way to decide between them using science alone. This is what philosophers call the cosmological argument in its most sophisticated form. Not the naive version where every event needs a cause, so the universe needs a cause, but the deeper version that asks, why is there a self-consistent, law-governed reality at all? Why is there something rather than nothing? And whatever answers that question, whether God or physics or mathematics, that thing is what we might call the ground of being, the ultimate foundation of existence. And reasonable people disagree about what that foundation is. Theists say it's God. Naturalists say it's some physical or mathematical structure. And I don't see how physics can definitively resolve that disagreement. Let me shift to another issue, because there's something else that comes up constantly in discussions of God and physics, and that's the question of miracles. If God exists, can God intervene in the natural world? Can God violate the laws of physics? Can miracles happen? Traditional theology says yes. The whole point of being God is that you're not bound by physical laws. You created the laws. You can suspend them when you choose. Walking on water, turning water into wine, rising from the dead, these violate physical laws, and that's precisely what makes them miraculous. But modern physics makes this picture very problematic, because we've learned that the laws of physics are universal and exceptionless. They hold everywhere and always. We've tested them in laboratories, in particle accelerators, in astronomical observations spanning billions of light years and billions of years, and they always work. No exceptions. If the laws of physics could be violated, we'd expect to see evidence of that. We'd expect to find events that don't fit our theories, anomalies that can't be explained by known physics, and occasionally we do find such things. But when we investigate carefully, we always find either an explanation within known physics or an indication that our theories need to be refined or that the observation was mistaken. We've never found a confirmed, replicable violation of physical law. Never. Now, this doesn't prove that miracles can't happen. Maybe God only performs miracles rarely in ways that don't leave clear physical evidence. Maybe miracles happen in domains where we haven't looked carefully or where the evidence would be ambiguous. But it does mean that if miracles happen, they're either extremely rare or they're subtle enough that they don't show up in our careful observations of how the universe works. And this creates a theological problem. If God exists and cares about humans, and if God has the power to intervene, why doesn't God do so more often? Why doesn't God heal diseases miraculously, or prevent disasters, or make divine presence obvious through clear violations of physical law? The traditional answer is that God respects human freedom and natural law, that constant intervention would undermine the integrity of creation. But that's a philosophical answer, not a scientific one. From a physics perspective, the universe looks like it runs entirely on natural law. Everything we observe can be explained, or potentially explained, through physics and chemistry and biology without invoking supernatural intervention. And this is why many physicists are atheists or agnostics. Not because physics has proven God doesn't exist, but because the universe seems to work perfectly well without God. The laws explain everything we observe. There's no gap where we need to insert, and then God did something. But here's where it gets interesting, because there's a different way to think about God's relationship to the laws of nature. Instead of thinking of God as occasionally breaking the laws, you can think of God as the reason the laws exist in the first place, as the ground of natural law itself. In this view, the laws of physics are the way God normally acts in the world. They're not constraints on God, they're expressions of God's nature and will. God doesn't violate the laws because the laws are how God works. This is the view of many sophisticated theologians and religious scientists. They don't see science and faith as in conflict because they don't think God acts by violating physics. They think God acts through physics, and that understanding the laws of nature is a way of understanding God's mind. And in this framework, the predictability and regularity of natural law isn't evidence against God, it's evidence for a rational, consistent, faithful God who creates an ordered, comprehensible universe. I have some sympathy for this view. It's intellectually coherent. It doesn't require rejecting any scientific findings. It allows you to be both a rigorous scientist and a sincere believer. But it does require giving up certain traditional ideas about miracles and divine intervention. It means reinterpreting Scripture when it describes violations of natural law. It means accepting that God doesn't directly answer prayers by suspending physics. That when we pray for healing, any healing that occurs will happen through natural biological processes, not through supernatural intervention. And that's a step many religious believers aren't willing to take. They want a God who actively intervenes, who performs miracles, who responds to prayer in tangible ways. And I understand that. There's something emotionally and spiritually unsatisfying about a God who only acts through natural law, who never breaks the rules, who's more like an abstract principle than a personal being. So you have a choice. You can maintain the traditional view of a God who intervenes and performs miracles, but then you have to explain why we never see clear evidence of this in our scientific observations. Or you can adopt a more sophisticated theology where God works entirely through natural law, but then you've changed what you mean by God in ways that might not satisfy your spiritual needs. Neither option is completely satisfying. And that's part of why this debate has persisted for centuries. Let me turn to another aspect of this, which is the question of purpose and meaning in the universe. One of the main reasons people believe in God is because they want the universe to have purpose. They want their lives to have cosmic significance. They want to believe that there's a reason we exist, that we're part of some grand plan, that our actions matter in an ultimate sense. And traditional religion provides that. It tells you that God created the universe for a purpose, that human beings have a special role in that purpose, that your choices matter not just for practical reasons, but for eternal cosmic reasons. Science, in contrast, seems to offer a very different picture. The universe is vast and old and mostly empty. Earth is a tiny speck orbiting an average star in an unremarkable galaxy. Humans are one species among millions that evolved through natural selection, a blind, purposeless process. We're here because our ancestors happened to survive and reproduce, not because the universe intended for us to exist. And when our species goes extinct, which it eventually will, and when the sun burns out and Earth becomes uninhabitable, the universe will continue on, utterly indifferent to our absence. In the long run, everything we've done, everything we've built, everything we've cared about will be erased. That's a bleak picture. It's the picture that leads people to say that science takes away meaning, that if God doesn't exist, then nothing matters, that without cosmic purpose, life is absurd. And I understand that reaction.